Welcome back. Next up, we're going to take a deep dive into how we can address ethical implementation of AI and improve confidence in AI solutions through explainability. Sal Gill of SAS is going to lead a discussion with Duke Energy, University of New Mexico, Eversource Energy, and Los Alamos National Lab to give us best practices and insights into how these two industries can better work together to explain how AI algorithms arrive at their recommendations and ensure ethical use of AI. Sal?
Thanks for that introduction, Christine. As the host of SAS's Electrifying AI podcast, where we bridge the gap between the greatest machine ever built, the electric grid, and the greatest enabler of our time, data analytics, it gives me immense pleasure to moderate this session with such an exciting group of panelists representing academia, R&D, industry, and utilities. So let's dig right into it. Ethics and explainability in AI are not mutually exclusive. To be ethical, AI must also become explainable. And any good ML model needs good data. So in a supervised learning environment, as an example, there's a need for a good set of classified training data, which we all agree. And if your training set has a bias, the model will have a bias too. And herein lies the challenge that we get to discuss today. So how do we define ethics and explainability becomes the first question. And for starters, explainable AI is the application of built-in processes to AI models that will allow human users to understand the steps and outcomes created by machine learning algorithms. Now, this understanding in itself can help solve the dilemma of ethics in AI. In fact, explainability and transparency refer to the entire analytical process, not just to an algorithm of machine learning that automates a decision. And it so happens that the status quo in AI research is the existence of a black box, which we so frequently hear in machine learning. And essentially, AI models intake so much data and create such complicated neural networks to meet their outcomes that researchers, a lot of times themselves, do not even know exactly what transpires in the collection and analysis of big data by these AI-driven algorithms. Now, these algorithms can detect specific patterns quickly, but they also don't give you the causality of why those patterns begin to happen. And recently we have seen outcries against racial bias and a lack of data privacy, which have mounted as AI has become more ingrained in our lives. And thus far, there have been few solutions. Now, the good news is that algorithms are not that dark. And although we cannot derive easily understandable sets of rules, we can, regardless of the concrete procedure, investigate the decisive factors in the algorithmic decision. Now, bringing this all back to our industry, the power and utility space, similar questions could be raised. So, for example, questions could be asked if we're using data to unintentionally bias future time of use rate parameters so that we're maximizing profitability instead of minimizing peak times. Another one could be, how fair and equitable are our energy forecasting techniques? Are our forecasts maybe taking parameters that show, for instance, electric vehicle forecasts being higher in affluent communities versus non-affluent, and hence driving greater grid infrastructure investment in those neighborhoods, whereas they may be needed somewhere else? And lastly, another one that comes to mind is, how are we using customer demographic data as an example to incentivize customer offerings? So one thought that comes to mind is around light bulbs, and reduced price light bulbs could be offered to anyone, but the nifty thermostats that I personally would also love to have one soon get offered to more affluent neighborhoods. So to address these and other challenges related to ethics and explainability in AI, I'm delighted to introduce you to our panelists for this session. So starting with Jaydeep, Jay is the program manager. Jay, if you can wave your hand so the audience can see where you are. Jay is the program manager for substation and transmission analytics at Eversource in Boston. He is responsible for building a strategy for the future grid intelligence products to support T&D infrastructure at Eversource. Jay's team has been instrumental in developing cutting-edge artificial intelligence tools for infrastructure inspections and assessments. He is also a member of and represents Eversource at IEEE and CGRE, both great and phenomenal organizations. Next, we have Norv. Norv, I love your shirt, MATLAB. We'll get to hear more about that during the discussion. Norv is the Director of Data Science Innovation at Duke Energy, focused on building high-performance analytics teams at Duke. He is responsible for leading advanced analytics initiatives and developing internal competency in emerging areas such as deep learning for video and image analytics and natural language processing. He is also co-founder and leader of Duke Energy's MATLAB, hence the shirt, which is dedicated to advancing machine learning, artificial intelligence, and deep learning. Norv, great to have you in this panel as well. Next, we'll go to Sandra. Sandra, if you can wave your hand. Perfect. Sandra is the chief scientist at Element Aero, which is a technological consulting company specializing in particle beam technology, security, and defense applications, and other environmental issues. She is also a research professor of electrical and computer engineering at the University of New Mexico. Her areas of interest and experience include the use of AI in controls, modeling, and prediction of complex systems, sensors, and detectors. And she's also an active member of IEEE USA's AI Policy Committee and the IEEE USA's R&D Policy Committee as well. Great to have you, Sandra, too. And lastly, Russell, if you can also wave your hand as well. Russell is a scientist at Los Alamos National Lab in New Mexico, where he leads the research and development of novel computational methods that address a variety of emerging challenges in infrastructure networks. He is also the co-principal investigator for the U.S. Department of Energy projects in critical infrastructure systems that focus on improving the robustness of grid infrastructure systems to extreme events, increasing resiliency of distribution networks, and modeling interdependencies between systems. Thanks to you as well, Russell, for joining us today. And so let's start the process and dig right into our panel discussion. So I'd like to open up by posing a question to all of our panelists, and that is, how can we combat intentional and unintentional biases in AI? And Russell, why don't I start with you? What are your thoughts on this from an R&D perspective, where usually these challenges first surface?
Yeah, and I think thanks, Alan. I think I'll echo some of your comments that you started out with, and I think where the research starts is with the data. The models that we use in AI and machine learning are only as good as the data that we use, and if that data contains a bias, then our models are going to be really good about learning what that bias is and taking that into and introducing that into the system. But that being said, there are quite a few methods that have been developed or are in development to try to identify where there is bias in data, or be able to recognize that bias is being introduced into the decision-making process that are associated with learning models. And this can range from things like statistical methods. There's a long history in statistics that looks at different ways of sampling and other techniques to try to control for bias, or just simple things within the methods themselves to sort of flag when there's an input that is well outside of what the training data has seen. And so rather than trying to fit that particular piece of input to what we've learned, just flagging it and using that for further refinement of the model. But at the end of the day, I really think that it's the data that's the key linchpin here, and trying to collect or sample from data sets that controls for biases is an important thing that needs to happen to try to correct for intentional or unintentional biases.
Very, very interesting response. Now, Norv, switching over to you, Duke Energy, one of the largest utilities in the U.S., covering several regions and states. Now, with that large of a presence across the U.S., how is Duke approaching this? Because you guys are generating so much data. and curious to hear what your involvement is in this.
Yeah, well, with some of the daily work, like Russell mentioned, there are some ways when you're selecting the data for training, you can have the built-in selection bias. So, there are some methods for designing around that or making sure you have a representative sample, and that's on a tactical level. But more strategically, we recognized at Duke Energy that this is something that people are concerned about, and some really big names across the world have run into scandals or unfortunate occurrences that you've run across in the media. And so we had a confluence of events where we in the Mad Lab working on AI solutions, we realized that this was something that we needed to look at and plan for and mitigate. And meanwhile, our leadership, the executive leadership at Duke Energy, had heard some of these stories about the new GDPR in the EU,
Mm-hmm.
and also California's data privacy, and then some of the other things, the Amazon hiring and the Facebook chatbots and so forth. And so they said, hey, we need to really get to develop our own AI ethical framework for responsibly managing and using artificial intelligence. And so we put together a cross-functional team across the enterprise to develop what we have called AI guiding principles. So we didn't develop a policy just yet. That's much more operational, but it's really a strategic statement of intent about how we want to make use of artificial intelligence, because we've realized that artificial intelligence is critical to our digital transformation, because Duke Energy, like most utilities, is transforming for the future in a challenging environment. And we've recognized that it's going to be an enabler for this transformation. So the guiding principles that we came up with, there were 5 pillars of it, fairness, transparency, responsibility, governance, and accountability. And each of those has a lot of detail, and each of those we played out in different actual scenarios with developing some of our products to refine that. And eventually that has been approved and is being socialized across the organization, and it will be sort of the statement of our AI ethical strategy that's going to be used to develop those operational, daily, practical policies.
Very, very fascinating. And Nora, just curious, this will be an enterprise-wide, or it is an enterprise-wide guideline. Is that correct?
Yeah, it went up to the C-suite and was approved. And since then, we've taken it to some of the main stakeholders. The data governance side, the data stewards, all the data stewards across the enterprise.
Right.
And next is going into change management so that we can develop some more content and training materials and help with the communications outside of the strategic level, but to all the workforce across Duke Energy that's involved with artificial intelligence.
That sounds very exciting. I think that'll be a really powerful use case for our industry, and I'm sure other industries too. But to implement that guideline across environments that are that have different regulatory jurisdictions would be a very, very interesting use case to follow. So in that same vein, Sandra, let's get towards you. And you are so actively involved in the IEEE AI space with the IEEE AI Policy Committee. What can you enlighten us with work that you have come across or that's being done to address this?
Sure. So I actually created a leave behind packet that I think EPRI will be able to post to folks after the event, and that has links to a lot of these policy statements. So I'm kind of, echoing a bit of what my colleagues have said. There's a need for these policies. It's derived from the data. There's been, as long as we've had data, we've had biases. So what has IEEE done? And I'll talk about a couple other groups as well. There's actually, professional societies that have data, that have driven these, guidance and advocacy in terms of policy statements, in terms of setting guidelines. So I want to first point to the IEEE USA, because they really answer to policy statements for the U.S. government. So there's 3 official policy statements if you just Google IEEE USA, and it'll also be in this leave behind packet, 3 policy statements One is just about to be uploaded. And just from there, it says to generate, I'm just reading from it, to generate sensible legal and diplomatic frameworks for AI, IEEE recommends that the U.S. government establish reliable, predictable, bias-free, and robust legal frameworks for AI systems. I can't read the whole thing to you today, but and then there's three other policy statements that are coming out that even talks about the equity, justice in AI, and democratic use. There's also IEEE standards. So we have the Standard Society, many societies in the IEEE. There's 420,000 members in this organization, and the Standards Committee, has set up the Wi-Fi standard. So they're also working on things for for standards for AI-driven systems, even for procurement. How do you go about buying something that is reliable? And this plays into something we'll talk about later in our talk. There's a group called the Oceanus, which is the Open Community for Ethics and Autonomous Intelligent Systems. Oceanus, like I said, there's in IEEE standards, there's ethical guidelines for aided design in the P7000 series. There was a White House statement that just came out on the 24th, and that's linked in my Leave Behind things. And then we also have to think if it's so I can say there's like technology bias, and then there's bias against certain groups. And so it's not just enough that we have data scientists and we have high performance computing and we have the sensors and we have this great autonomous system. We have to also consider people like ethnologists, sociologists, anthropologists to help us guide our way through this. So there's a group between UCLA, NREL, and LA County Power, LA City Power and Water. So they're actually looking at trying to make this balance. So really, playing into some of these models. And I'll just mention one other thing that, our data also, when we're architecting a system, we also have to take a step backwards and say, okay, what's the bias? Are we biased to a certain technology? If we look to Sweden, for instance, there's they make so much power and it's all green, and they'll totally carbon neutral. They make so much and they send it to Denmark, and they keep the prices low for everyone. So how can we transfer that knowledge and to our models? Anyway, thank you.
Sounds like there's some promising work being done in the IEEE arena on this. Jay, quickly coming to you, any feedback or any thoughts on how Eversource is approaching this topic?
First of all, great points raised by Norv. I think they lead the industry in terms of adopting AI in the company, especially the energy utilities world. I'll just add one additional point here, which is the bias or removing the bias goes well beyond just the AI trading part. A lot of it is just a cultural bias, and we have to understand that people build models, people label data. So to remove the bias, it goes beyond just data scientists or people who are labeling the data, but it's at organizational level as to how are we communicating with our organization, and so that the people who are in positions to make these decisions are already trained to spot these type of situations and spot these traps before we run into those. So I'll just leave it at that.
Perfect. No, great insights. And to our audience, thank you for sending a lot of questions already in our first round. Appreciate it. And I think, Jay, this is one question that's come up from the audience, and that is, can the speakers describe a specific situation where they've dealt with biased data and corrected it? I think that there may be some scenarios. Are there any scenarios you have come across at Eversource, or Norv, you at Duke, perhaps?
And then Jay can chime in. Looking at the selection bias, from a quantitative analysis perspective, separately from how the word bias is used in terms of ethics and HR and so on. But we've had, for example, we're using drones to inspect solar farms to identify
Mm.
when panels or strings of panels have stopped working. And so, originally we trained it on a few of our solar farms out in the field, and did great. But then we moved to a different area of the country which used different hardware, and the model didn't work as well. So that's an example of selection bias, building a bias into the
Mm.
training, which then builds a bias into the outputs. So we had to retrain it with a whole lot more variety in the makes and models of the solar panels and inverters. But yeah, so there's a
No.
meaning of bias when you're talking about the training data. There's also a bias as it's used in terms of neural networks parameters. So when we talk about bias, we need to be clear about what we're doing. But in terms of the actual, personal demographics, um, I don't have one that springs to mind, but it's something that we're aware of, and it's been a key point of our discussions. Um, and we've also had some interesting conversations with our colleagues here in Charlotte, which is a big financial center. And it's interesting that I wasn't aware of it until we spoke with one of the senior directors of analytics from one of the big credit card issuing banks. And he
Mm.
said that he was really excited one day when we were talking to him. And he said he was really excited because he'd just gotten compliance to approve them to use extreme gradient boosted trees as a model for them to, you know, um, review and approve credit card applications. And he said they never could use neural networks for it because exactly as you said, Sal, it's a black box. It was difficult to explain. So if you would approve somebody with a neural network, that's fine. But if you reject somebody's credit card application, they'd say, "Why did you reject?" You can't explain it. Then you could say, "Well, you did it based on some sort of
Right.
protected status," and you might have a tort.
Interesting. Interesting. I know Jay is having some technical issues, so we'll move on here, and please keep the questions coming. Um, and Norv, to tie that back in, I think this is a nice transition here from an example of a bias. We hear a lot about customer centricity. It's become a very, very hot topic over the last couple of years. So another area of deep interest to consumers then is the biases that can be introduced in potentially in demographical data. So to both Norv and Jay, we'd be curious to hear how you guys are using customers' demographic data, and how do you go about addressing the issue of any biases that can be introduced, leveraging such data in your analysis. So Norv or Jay, whoever wants to go.
Sure, I can take a stab at it. I think specifically when we look at the demographic data, there's a very high chance that unintentionally we introduce bias and kind of get somewhat carried away is probably not the right word. But if we purely evaluate a model on a base of, let's say, R2 score or goodness of fit, then it's very easy to say that the model works perfectly and completely overlook what feeds into it. So specifically thinking about something like median household income or in general, parameters that capture wealth of a neighborhood, those parameters tend to correlate well with certain attributes in that neighborhood. And I think that's a classic trap in my view when we analyze certain types of situations. So I think that's a classic example where we have to be more deliberate with what kind of data goes in and intentionally not include those type of informations when we train the model, just so that it doesn't become heavily biased towards a certain type of demographic.
Perfect. And thanks for mentioning R squared. It took me back to my memories in college when I was taking statistics courses. Really interesting. Norv, any insights from you?
Yeah, I think there used to be a greater risk of that in the past. The leaps in the technological capabilities have really brought down the price of marketing. So in the past, when we actually had to mail out, physical letters with envelopes and
Mm.
postage and so on, we had to, develop a target audience of a few thousand or what have you, because we have 7.5 million customers. If we wanted to send something to everyone, pretty soon you're talking about real money. Um, but nowadays it's all done with emails. So for those types of energy efficiency products and services, um, we try to contact everyone who's qualified for the offer.
Okay. And on that point, there's also a lot of hot discussion around climate change, energy equity, and are there ways that we can use AI to inform the decisions utilities, in this case, make in order to ensure that this ongoing energy transition that we're all going through is equitable and non-exclusionary? Certainly, again, with utilities, so many assets, so many data points. Norv, why don't we take it back to you since you were already on that point?
Yeah, we are doing a lot with moving towards a net zero carbon goal by 2050, and we're already 40% of the way there since 2005. So we're, like I mentioned, the one with using drones to inspect the solar panels. We're doing that on our commercial, and then separately we've got another product on our regulated renewable side, and we've also developed an AI algorithm to examine the outputs of those solar farms and to classify if there is an undergeneration, what's the cause of it, and then to suggest these are the steps that you can take. And that's a neat. It's quite an impressive product that's under patent pending right now. So, but yeah, we are using IT for a lot of renewables and to help us to move down our journey towards our goal of net zero carbon by 2050. And then on the other side, we also have 1.6 million natural gas customers.
I think we lost your audio there, Norv.
Yeah, I just had a phone call coming in. It took over my headset. But we've also got 1.6 million natural gas customers, and we're moving towards a net zero methane emissions as well. And we're using computer vision and artificial intelligence to detect methane leaks. So all these things are helping us as we move towards a carbon constrained future.
Right, and Jay, I know you have a very core interest in EVs, and there's some great work being done in your area in that light. Talk to us about how Eversource may be looking at issues with where EV charging infrastructure may be getting deployed, or perhaps how you're factoring in different variables than the conventional ones that come to mind when you're planning for such investments.
Yeah, absolutely. And I think we definitely see an opportunity to use AI in forecasting the demand. And especially we consider ourselves or our peers, we are all facilitating this transition towards net zero grid per se. And I think the bigger question is how do we forecast the demand? And let's take an example of EV charging, what you just mentioned. I like to think that in this particular case, past is not a representative of what the future holds. So for instance, if we take a classical machine learning lens and we say that I'm going to build a classifier that takes into account certain information about the customers who already have electric vehicles or the neighborhoods where we already have charging stations, you can walk away with a really, really good classifier. But what you will ultimately find out is the underlying factors that influence that location of the load or the demand are heavily influenced towards more affluent neighborhoods, for instance. Just because up to 5 years ago, the median price of electric vehicles was $75,000, and it's likely to drop over next decade. So in cases like these, we have to be very deliberate with how we make those decisions, even though on paper, the model might be supremely good at identifying locations or neighborhoods or zip codes. So I think a lot more work goes into it, and adding nuance is very important in cases like these.
Very interesting. We'll revisit that topic in a few more minutes. Sandra and Russell, coming over to you guys. What sort of academic and R&D efforts are ongoing into researching ethics and explainability in your realms? And if you can point us to any specific examples related to this issue in our area of electricity or energy, So, Russell, why don't we take that over to you first?
Yeah, thank you, Sal. So, I think one example, and Sandra will probably get to this a little bit, is I think there's been a lot of exciting developments with the professional and academic communities like IEEE and AAAI to sort of provide guidance and policies to researchers on how to develop methods that take into account ethics and explainability. So I think that's sort of step one. But then there's sort of at the technical level, there's a number of communities within the AI world that are trying to tackle this problem from a number of different angles. And I think sort of one specific example would be the physics-informed machine learning community. And so they're looking at problems like power systems, natural gas systems, where there's a wealth of domain knowledge when it comes from the physics, engineering limits, things like that, and trying to bake in that domain knowledge into the AI methods. Because by providing that knowledge to these models, it really helps to explain the outputs and the solutions that we see. And so, looking at these communities, what they're doing, I think that they're trying to, is a specific example for power systems.
Wonderful. Sandra?
Yeah, I'd say maybe not so much researching, but we're trying to couple in, concepts of ethics, explainability, and interpretability. I think we have to maybe expand that, the definition. They're both hot topics, but they're not decoupled. Explainability and interpretability. So in our own courses, the courses of colleagues, people are trying to incorporate, and in the research. So I already pointed to the, mapping in, folks from anthropologists like ethnologists, and also, considering climate change may not be immediate in every model, but we have to be cognizant that, if we start going down one road for technology, and so this is speaking to something specifically at University of Chicago, some research there, that you have to be certain that you have the climate change models embedded, because eventually at the end of the day, the next polar vortex, it may not actually be the technology that you have that's going to survive that for a week. So that all has to be coupled in the model. So it's like a data bias, just because we may want to see that solution, and I already touched on that. If we look at like the Class A truck study, something's just about to come out. Can we make it all these Class A trucks electric, for instance? And so you can only get for a 500-mile run, electric, batteries are not going to cut it. We have to fold in, hydrogen. Actually, the study is just about to come out, but these are just examples. And then my close colleague that I work with at University of New Mexico, he's working on, it's one of the poorer states, New Mexico EPSCoR Smart Grid project, and they're really heavily looking at interpretability more than explainability. So then they have to avoid the bias, but they have to be able to model the data so they know where an anomaly may happen, because they want to work on this adaptive protection. It's explainable in terms of it's deviation from the expected behavior, but they have to be detected, because it could be belonging to this intrusion of a fault. But what if that anomaly is actually a novelty and not related to the past? So what the data speaks, right? And I think the explainability comes with refining the model over time as well. So those are just a couple examples of what's happening in academia.
Very, very interesting. And Sandra, I think this question just came in from the audience, and I think it's very relevant to what you've mentioned here. But perhaps you can shed some more insights. The question is, in the past, we have seen that AI can continue to reinforce past biases, whether against women, minorities, or other groups. What corollaries do you see in the electric power industry that we should watch out for? And obviously, it's open to everybody else as well. But Sandra, we can begin with you first.
Yeah, actually, we talked about the marketing. If you think about surveys were done years ago, everybody knew everyone had a house phone. That's where surveys were made. Now we don't actually know who we're talking to. How do we get the right data from a certain group or a certain area, whether it's a poor area or an affluent area? I think that you have to connect the same people to one another to get all the data from those groups. And then also even saying that, marketing via email, during the pandemic, we know, like in Chicago public schools, many of the students didn't even have internet or a computer. And so did we just, going from paper and pen, sending, some marketing material, did we eliminate somebody by changing to all electronic? So that's what I see.
Sure. Jay, any insights from you on this topic?
No, I mean, I agree with everything that's said. Nothing to add on this.
All right, perfect. So let's move on to our next important topic as well, which is the demand for clear explanations about how decisions are being made, or how these models are driving analytical decisions to reach their conclusions. And in my world, being on the vendor side, I deal with a lot of customers. And coming from a company that has been in the analytics space since its inception, I hear a lot from regulators, even in our industry, that are asking for more defined, clearer explanations, going deep down into truly understanding how, for instance, even energy forecasts are being developed. As obvious that too obviously impacts rate cases or potential rate cases that may be coming up. So this question is open to all panelists, and we can start with Russell first. Is our industry even prepared to break down these complex algorithms, models, black boxes into perhaps glass boxes?
It's a tough question. And, within the research community, it is recognized that this is a open challenge. And I think if you look at the main conferences in this area for the last several years, you'll see special tracks devoted to this topic, and people are really trying to solve this problem. Now, in the short term, in my experience, what I've seen is there's a general gravitation in the applied world to use simpler models, because you can actually kind of dig in and understand what they're doing and how they came to their conclusions. And I think the overall goal of the research community is to try and bake that type of simplicity into the more complicated models, so that you can actually derive some explainable or understandable results.
Wonderful. Norv, I saw you nodding your head too. Would you like to add anything to it?
Yeah, I mean, for the same reasons that Russell described in some of our earlier conversations, the explainability is important, especially if you're dealing with customer data. I mean, I suppose it might be less so if you're trying to determine, for example, whether this nuclear, cooling pump has a leak or not. Introducing bias into that isn't going to hurt anybody's feelings. But yeah, we are, interested in finding ways to better explain the outputs. And one of the things that we've seen that we've kind of liked, it's kind of an immature function, but some of the AutoML platforms have the ability to generate reports that document the features and their various weights and Shapley values and so on, which can go a long way to quantitatively explaining how the model is using those features. But you still need to have a seasoned data scientist to be able to, or a quantitative analyst to be able to interpret those things. So there are some tools that can be that I hope will be developed that can help us to answer that explainability conundrum.
Yeah, that's interesting. We all know that there's a lot of grid edge deployments that are taking place. So we have these power electronic inverters that are going out there. We have intelligent electronic devices that are being put, more and more IoT devices getting integrated. And so Norv, sort of transitioning from the point that you made there, How are utility teams looking at innovative data set use cases where perhaps that data is so new that you don't even have a bunch of historical data to make analysis? And you talked about auto ML. Jay, I'm curious to get your thoughts on this as well. Where do we are one thing that you mentioned, Norva, is that auto ML is providing some explainability, but on the other end, are we also becoming dependent on such techniques as well, especially if you look at it from a broader perspective, the talent shortage in the market? So I'm curious to get both of your thoughts on this topic. Jay, why don't we go to you first?
You hit the perfect point. I think AutoML is a very interesting tool that I think you will see more and more utilities and energy companies embrace because it offers a tremendous amount of flexibility and all these new features that they're developing to have model explainability, version tracking, and all of that. They're very useful. So I think it's a very important tool to have in arsenal, but at the same time, we can't discount the need of a trained individual who acts like a gate check mechanism before that model goes into production, just to make sure that everything checks out. And I just want to share a very interesting example of one of the studies that we were running. We were building some load model, and suddenly our model wasn't behaving as well in the month of August. And we tend to be on the side of caution, and we trade accuracy for explainability. So we go for simpler models versus super accurate, very complex models. And long story short, we pinned down the cost to be the scaler that we used to scale the variables, and the scaled variable was temperature. And the reason was we had historic temperatures in Boston. We had never seen heat wave as bad in the history, so our scaler never had seen that type of data before. Now, we can pinpoint that to an innocuous mistake and move on, but I think it goes much more beyond that. Just because we had a simple model, we could quickly trace back that error that we had seen in the model and pinpoint to a cause and fix it iteratively really, really quickly, because we found that because of climate change, the peak temperatures are increasing. So we have to account for that and not just rely on historic temperature for scaling that variable. Would love to see what NAR has to offer on this.
Yeah, sure, Jay.
Nor?
Yeah, thanks. Referring to the AutoML products themselves, we see two audiences and two big benefits that we could get out of them. One, like you mentioned, Sal, about the competitive nature of the data science job market, as we think that it has the potential to make our data scientists more productive. They can generate more models and work on deliver more products more rapidly and more productively. And we've liked a few of the products that we've seen for doing that. And then on the other side, which is where some of the risk comes in, we've been approached by a lot of people who really intrigued by the work that our team does and would like to get involved in it, but they're not really trained data scientists, and so we call them citizen data scientists. And so those are people who could use the GUI to build a model, but then might not know exactly what they're doing, but just put the pieces together and have it spit it out and not truly understand the fundamentals. And so there is some risk in there, and so we've people have done things like that in the past that's caused some a kerfuffle from time to time. So we've always wanted to include a senior seasoned data scientist to check the model and to check the process before anything goes out the door.
Interesting. So it sounds like we're saying there's a need for a machine learning operations strategy with a governance structure of some sort to be implemented. Russell, I know this topic is deep. You're very passionate about this topic as well, and it also appears that there's some trade-off here between the robustness versus the cost equation here. You want to share some thoughts or sentiments on this?
Yeah, I think with auto ML, not just in the energy systems, but in general, I think there's an overarching goal is that you'd like to have that model be able to handle any input and basically do something sensible with that input. Now, of course, the more inputs for which you are going to be able to handle gracefully, you're going to have some sort of trade-off, whether that's slowing down the response time of the ML algorithm or operating your system further away from the engineering limits. Basically, you're going to lose some opportunity costs when it comes to either efficiency or economics. And so, I think my personal passion is having within these AI methods the ability to kind of look and analyze how robust your method is to different inputs, and then being able to use that as a parameter of the model. So be able to increase the classes of inputs that you're able to handle, and be able to look at what do you get in terms of robustness versus how much is actually cost to gain that particular robustness. And that provides information to the deployer of these tools to be able to find that sweet spot between how robust those ML methods are and how much you're going to lose in terms of opportunity costs. And I saw an earlier question. It was kind of interesting. There was in the chat about are we holding our ML techniques to a higher standard than we hold our humans? And I think, especially with auto ML, I think we almost have to. Humans have built-in slowness properties that computers don't have. And so if a computer goes off and makes decisions, it can do it really fast and things can spiral out of control quite quickly. Whereas a human, there's more time in which to correct mistakes and things like that. And so I think it is important to hold our AI methods to the higher standards than we hold our humans.
Very interesting. So this topic brings another topic in mind, which is accountability. And the question to me then becomes, where does accountability lie in this entire process related to ethics and explainability? Or if it doesn't exist today, where should it be built in? And more bringing it more to the data scientist. Is it then the responsibility of a data scientist to know about who and how their models will impact, or is it with the person who's consuming that model, not the one who's developing it? So Sandra, maybe we go to you, and perhaps you can shed some light on your thoughts. If it's both of them, if it's none of them, if it's a totally different model that needs to be explored.
I mean, I think we're just coming back to the models for a second. Like, there's only one model of the universe, and it's the universe, right? And so we break things down. And from that, we have to, the accountability comes into play. Like, we don't really have control over somebody. If somebody that's going to use a medical device, or somebody that's going to drive a car, we can only make so many safety features, right? But we can step back and say, what have we done in terms of systems engineering? What have we learned from many systems engineering processes, and how can we follow those kinds of standards or approaches to think about how we can kind of better interlock our models, so that we can guide, as Norv was saying, that you can only, only a seasoned data scientist will really be able to understand what they're creating by a GUI-driven AutoML system, right? But how can we guide them better, and how can we keep coming back and making a better GUI, and how can we build that safety in? I mean, if we look to nuclear reactors, right, there's all these built-in safety systems, right, and it got better and better over time. If we the goal is to have zero radiation. The same with locking somebody out of a particle accelerator. You have to just drive down that risk. So I don't think that you can decouple the user from the data scientists. They have try to be aware of what they're going to use it for, but at the end of the day, you can't ultimately control it. So I think we have to just build it into our ML and AI applications.
Interesting. Jay, in our background,
training. Sorry, I was just going to say, I think some of this comes with training. I think there's many university-based programs, and then there's also education with IEEE and AI standards that can also, we as a community could be contributing to these standards to help make drive these models to be safer.
Got it. Right. And Sandra, your points there spur an interesting thought in my mind, which is around curiosity or asking the right questions to some extent. And Jay, bringing that over to you at EverSource, what sort of mantra do you use with your team when you're out there designing these solutions in an ever evolving grid that we all know which has become?
Yeah, and so we like to think that, and it's true for any data science team or companies, you cannot decouple data science from the domain knowledge, right? So you always have to add that shade of what that decision means for the company or for the customers, right? Like if there's a dispatch decision to be made, and if someone is going to lose power, uh, we better make sure that that decision is made correctly with the model, right? So a question that we ask our team members all the time is put yourself in the shoes. Like if you think that a model is going to evaluate whether you're suitable to make a certain decision or not, or you're likely to make a certain decision or not, put yourself in the shoes, put yourself in different uh, scenarios and see if your profile really gives the output that you would like to see, and simultaneously going beyond personal data, looking at broader system decisions. We always ask these questions as to what's the consequence of these actions? What is it going to do? Is it doing the right thing or not? And are we evaluating the breadth of impact that those actions are likely to drive?
Jay, is there a specific example that you can share, uh, a solution perhaps that you were developing where you applied this?
Yeah, so going back to what we were talking about EVs earlier, right? So for instance, talking about the same example of the median cost of EVs, which is likely to drop over next decade, right? So if you're building a model to estimate, let's say, load growth in neighborhoods, I always say this that put yourself in that model, like feed yourself in that model and try to see if that model spits out the correct output for you. Like, are you likely to buy an EV or not, or are you likely to convert your appliances at home to electric appliances or not? And does the model truly capture everything about you with the data that is being fed? And I know this is very specific to a person, but putting yourself in the shoes could go as big as relating to a neighborhood, relating to a zip code, relating to a substation, for instance, and just figuring out what who are we trying to serve, and what is the end result of our actions.
Very interesting. I love those quotes. We need to posterize them after the session. Norv, bringing it to you, how similar or different is Duke's approach versus from what you're hearing from Jay? How do you guys tackle this?
Yeah, customer centricity is one of the um, core components of our digital strategy, our digital transformation. And Duke Energy is transforming for the future to try to become, a 21st century utility. So we're investing close to $60 billion in capital over the next few years to develop a resilient grid operations, including things like two-way power flow and a lot of distributed energy. And with and AI is a crucial enabler of a lot of that. But the three main objectives that we're um, trying to deliver with our digital strategy, one is intelligent operations. Running the grid in the most effective and cost-effective and safest and productive way. And two is with digital workers, so that our people on the ground have the data that they need, have the information and the training and the tools that they need to make the grid operate in a safe and productive manner. But then the third pillar of our digital strategy is the connected consumer. So we want the consumers, we want to have intimacy and have their interactions with us be frictionless, and and for them to be delighted by the outcomes of working with Duke Energy, instead of only calling us when they have an outage. or have a complaint about their bill.
Right.
So that's the usual contact points. So yeah, the customer centricity is a core of our digital strategy and our overall digital transformation journey.
Interesting to also see two large players aligning on and having complementary thoughts in this space. So, folks, we only have about 5 minutes left, 4 minutes, 50 seconds to be exact. I'd like to take this opportunity to ask each of our panelists to share their final thoughts or words of wisdom on this topic related to ethics and explainability. You heard from me in the beginning, where I mentioned that ethics and explainability are not mutually exclusive. They're tied together. They're joined together. Russell, I'd like to start off this final round with yourself. Any final words from your end?
Yeah, I think I would. Final thoughts would be, when I go to the AI workshops and conferences, generally speaking, you'll see sort of light attendance from the energy system sector, and so I would sort of encourage this application domain, because it's such a fruitful area for AI techniques, to participate in some of those meetings, because I think that's a way for this community to influence the direction of AI in a pretty dramatic and exciting way. And so I think sort of my parting comment is that encouragement to those in the audience.
Thank you. Sandra?
Yeah, I kind of want to echo what Russ had said, that, a lot of the things that I discussed in terms of the policy and things like Oceanus, it's a great way that people can get not just IEEE, but Oceanus is global. Really the energy sector could have a huge influence on how policies are built, recommendations, even designing new courses for AI in ethics and design, have that input into these courses that are being developed and being held. Most of these courses are, continuing education with different professional societies, but it's something that EPRI could, get involved with also on the policy side. And I think it's constant education. This is a new tool in the first session today. AI and ML is just another tool, just like high performance computing is a tool, just like better sensors are a tool. All of these things are tools, and as we make these more complex technologies, it's just that our what we need in our toolkit just gets enormous. So we have to keep training. So continuing education, I think, is a big part of it, and engage in that discussion with these other organizations.
So education and training, core components, very, very relevant. Norv, to you.
Yeah, sure, Sal. Yeah, I think that this issue is going to continue to emerge for utilities around the world, not just in the U.S. But we've seen in the course of our digital transformation and our journey from basic analytics to data science to artificial intelligence and so forth, as we're developing stronger skills and a larger team, people are becoming more ambitious, want to do more with the know-how that we've got on our team. And as it becomes closer and closer to the core operations of the utility, we have to make sure that we have a rigorous means of governing that, to make sure that we're not taking on or introducing any unnecessary risks. So developing these AI ethical guiding principles is going to be something that's going to be, in the next few years, going to be universal across the utility industry, I think, the same way it is across a lot of the software industry. When we started, to research the concept of AI ethics and guiding principles, we canvassed a lot of those, and we found that, IBM and Microsoft and Bosch and, we also looked at some, international organizations like the OECD and the IEEE, and there were statements of AI ethics, but not a lot of utilities had them. But I think that's going to change in the coming future.
Okay, perfect. Jay, you get the golden 20 seconds. So floor is yours.
Absolutely. I think everyone has made great points. I'll just lastly say that no one person or no one body has all the right answers. So it's important to have a dialogue. It's important to exchange ideas, best practices, and I hope that people in the audience as well as on this panel will continue this dialogue.
Wonderful, wonderful. Well, thank you to all of you. It's been an honor doing this with you. And hopefully next time we get to do this in person. To our audience, if you've enjoyed this session, please connect with us offline. All of our contact information should be available through EPRI. And do also stay tuned to our podcast, Electrifying AI, where we too get into these discussions in a very informal manner. Thank you, EPRI, for the opportunity. And Christine, back to you.
Thank you, Sal. That really was a fascinating discussion on ethics and explainability, which really are the foundations for successful AI adoption, right? Having a governance structure, accountability, setting expectations for AI models collaboratively, all essential to enterprise-wide endeavors, and a great way to end our panel discussion for today. All right, we're going to head into our last break with a 2-minute quick video showcasing an overview of EPRI's AI initiative. So I invite you to watch before you head to your mid-morning or mid-afternoon snack, whatever time zone you might happen to be in. We'll see you back here for our grand challenge session in 30 minutes, and enjoy the video.
From AI automation for grid-integrated buildings, to wind turbine maintenance enhancements, to natural language processing dictionaries for nuclear plants, our R&D teams are advancing solutions that will reshape the electric power industry.
Well, we are starting an exciting decade where the industry has come together, and we have all committed to a net zero future. But that future needs to be resilient, reliable, and affordable.
As we look to the future, the energy network is going to be different than it is today. There's going to be more assets that are on the grid. We're going to have distributed energy networks, and that's going to create more data, more information, and different types of decision making. And artificial intelligence is going to be a part of that as we move forward into the future. Imagine an AI model that could perform a review of a report that typically takes a human 12 minutes to read in just a fraction of a second. We're working on a nuclear plant dictionary to multiply the effectiveness of natural language processing that will help plant staff review corrective action reports much more efficiently, significantly enhancing maintenance operations.
The digital transformation of the industry is going to be essential, and artificial intelligence and other data analytics is going to be a key enabler for the digital transformation.
Join us as we build an electric power and AI community and be a catalyst for shaping tomorrow's energy network.